Go. Okay. All right, vectors. Vectors had 5 steps for addition. So it doesn't matter what vector you're using. I should mention that. Vectors are anything that's got a direction. So this could be displacement. It could be velocity. It could be acceleration. It could be force. It could be momentum. It could be energy. It could be just about anything. All right? It could be a vector. But you add them all in the same way. There were 5 steps for adding vectors. So the 5 steps for adding vectors were as follows. 1, add your x direction. Add the stuff in the x direction. Add the stuff in the y direction. All right. Redraw. Pythag for Pythagorean theorem. But I never can spell Pythagorean, so Pythag. And then 5, find the angle, which is inverse tangent y over x. Now, this is where the magnitude and direction comes in. Because if it says, tell me the magnitude of the force, of like the net force, you just need to figure out the Pythagorean theorem. If it says to find the magnitude and direction, you need to do Pythagorean theorem and the angle. Alright, so let's just give an example real quickly. This is a simple one. We'll say there are 4 forces acting on a box. 5 newtons down, 6 newtons up, 3 newtons right, 1 newton left. Okay, so you could plug this in, follow our steps, add x. Key thing note, it's not 4, it would be 2, right? So the x would be 2, y direction, 6 minus 5 would be 1. We would redraw it. You always draw the x first, 2, then the y, 1. This right here is known as our resultant. All right? And the way you write it at the end is you do the resultant equals the r you found from the Pythagorean theorem at the angle theta. So for instance, here you would do r is equal to the square root of 2 squared plus 1 squared. So the resultant would be equal to the square root of 4. No. Sorry. 5. Square root of 5. And then if you wanted to figure out the angle would be equal to inverse tangent 1 over 2. And you could figure out the angle. Alright. Last thing on vectors is this. If you have stuff at an angle, right? Let's say that rather than have it simple like this where they're all on the x or the y, if you have one that's like 5 newtons at 37 degrees, I'll use meters per second here just to show that it's not the same. 5 meters per second at 37 degrees, 2 meters per second down, and 1 meter per second this way. What you would do is you add in a 0 step. You have to break into components first. Whoops. Into components. There we go. Break into components. So you got to do that first. So we need to break 5 into components. So this would be 4 meters per second in the x and 3 meters per second in the y. After we do that, we can do the same thing. Add x, add y, redraw Pythagorean theorem. So like if we added x, we would get 3 meters per second. Add y, we would get 1 meter per second. And then we could do all the other steps that we just did. All right? So if it's at an angle, you have to do Pythagorean theorem, or sorry, you have to break it into the components first. By the way you break it into components, whatever it is, the resultant in the x and the resultant in the y are always equal to r cosine theta and r sine theta. Okay? Questions?
Concerns?
Answers? All right. All right, excellent. All right, thanks for bearing with me. Tomorrow we'll go over